Hi students, in this session we are going to learn 7th standard mathematics chapter 1 integers topic division of integers. In this chapter we are going to cover the topics of division of integers and properties of division of integers. Let's see the properties: closure property, commutative property, associative property, zero property and identity property. Let's see division of integers. Division is the inverse of multiplication. Division of integers is the opposite operation of multiplying integers. It is the process by which one is trying to determine how many times a number is contained into another. Let's see the example. 2 4s are 8. 8 divided by 2 is equal to 4 or 8 divided by 4 is equal to 2. Therefore, division is the inverse of multiplication. Let's see division rules of integers. When we divide a positive integer by positive integer, we get positive integer. When we divide a negative integer by a negative integer, we get positive integer. That means the quotient of two integers with like sign is positive. When we divide a positive integer by negative integer, we get a negative integer. When we divide a negative integer by a positive integer, we get negative integer. That means the quotient of two integers with unlike sign is negative. Let's see division of integers. Case 1. Both integers are positive. When we divide a positive integer by a positive integer, we get positive integer only. Let's see some example. Plus 85 divided by plus 5. Now we have to divide. You must know the tables. Here 85 is dividend, 5 is divisor. 1 5 is 5. 8 minus 5 we get 3. Subtract the numbers. Now bring down 5. We get 35. 7 5s are 35. Now we have to subtract 35 minus 35. We get 0. Therefore, plus 85 divided by plus 5 equal to plus 17. Quotient is plus 17. That means when two integers are positive, their quotient will be positive. Let's see case 2. Both integers are negative. Both integers negative means we get positive integer only. Let's check it. Minus 36 divided by minus 4. Now we have to divide the integers. 36 is dividend, 4 is divisor. 9 4s are 36. 36 minus 36 we get 0. Quotient is plus 9. That means when two integers are negative, their quotient will be positive. Let's see case 3. One integer is positive, other integer is negative. When we divide a positive integer by a negative integer, we get negative integer only. And when we divide a negative integer by a positive integer, we get negative integer only. Now we can check it. Let's see example 1. Plus 28 divided by minus 7. Here 28 is dividend, 7 is divisor. Now we can divide. 4 sevens are 28. Now we can subtract 28 minus 28, we get 0. The quotient is minus 4. Let's see another one example. Minus 56 divided by plus 8. 56 is divide and 8 is divisor. 7 8s are 56. 56 minus 56 we get 0. The quotient is minus 7. Therefore, when one integer is positive and other integer is negative, their quotient will be negative. Let's see properties of division of integers. Let's see closure property. If a and b are any two integers, then a divided by b may not always be an integers. Let's check it. Example 5 divided by 2, which means 5 divided by 2, which is not an integer because we have to divide both integers, we get decimal number only. Let's see another one example. 30 divided by 5 is equal to, we get 6. 6 5s are 30. We have to divide, we get 6, which is an integer. That means if we divide an integer by another integer, we may or may not be an integer. Let's see commutative property. If a and b are any two integers, then a divided by b is not equal to b divided by a. Let's see the example. Here given a equal to minus 9, b equal to minus 3. Let's check LHS. A divided by b is equal to, substitute the values, minus 9 divided by minus 3. Look at the sign. When we divide a negative integer by negative integer, we get positive integer. Therefore, a divided by b is equal to minus 9 divided by minus 3. Now, cancel the sign. 1 3 is 3, 3 3 is 9. We get a divided by b is equal to 3. Let's see RHS. B divided by a is equal to, substitute the values, b equal to minus 3 divided by a equal to minus 9. We get minus 3 divided by minus 9. Here also same rule. We get minus 3 divided by minus 9. Cancel the sign. 1 3 is 3, 3 3 is 9. We get 1 by 3. Therefore, 3 is not equal to 1 by 3. LHS is not equal to RHS. Therefore, a divided by b is not equal to b divided by a. The commutative property does not hold good for division of integers. Let's see associative property. If a, b and c are any three integers, then a divided by b divided by c is not equal to a divided by b divided by c. Here, left hand side a and b are grouped. Here, right hand side b and c are grouped. Let's see the example. A equal to minus 40, b equal to 4, c equal to minus 2. According to the statement, a divided by b divided by c is not equal to a divided by b divided by c. Let's check LHS. A divided by b divided by c. A and b are grouped. Now substitute the value. Minus 40 divided by b value 4 divided by minus 2. Now we can solve inside the bracket because this one is grouped. Minus 40 divided by plus 4. When we divide a negative integer by a positive integer, we get negative integer only. 40 divided by 4, 10. We get minus 10 divided by remaining minus 2. So the expression is minus 10 divided by minus 2. Now a divided by b divided by c is equal to minus 10 divided by minus 2. Now cancel the negative sign. 1 2 is 2, 5 2s are 10. We get 5. Therefore, a divided by b divided by c is equal to 5. Let's prove RHS. A divided by B divided by C. Here B and C are grouped. That means now substitute the values. A equal to minus 40 divided by B equal to 4 divided by C value minus 2. Now we have to solve in inside the bracket first. 4 divided by 2. Positive integer divided by a negative integer, we get negative integer only. 4 divided by 2, 2 2s are 4, we get minus 2. We get the expression minus 40 divided by minus 2 equal to minus 40 divided by 2. Now cancel the sign. 1 2 is 2, 22s are 40. A divided by B divided by C is equal to 20. Here LHS is not equal to RHS. Therefore, A divided by B divided by C is not equal to A divided by B divided by C. Here 5 is not equal to 20. Therefore, the associative property also does not hold good for division of integers. Let's see zero property. 0 divided by any non-zero integer is 0. If A is a non-zero integer, then 0 divided by A is equal to 0. Let's see the example. 0 divided by minus 2, we get 0. Let's see another one example. 0 divided by 4, we get 0. Therefore, 0 divided by A is equal to 0 only, where A is not equal to 0. And an integer divided by 0 is meaningless and hence not defined. Let's see the example. 5 divided by 0 is equal to not defined. Another one example. Minus 10 divided by 0 is equal to not defined. Let's see identity property. If A is an integer, then A divided by 1 is equal to A. Let's see the example. First one, 7 divided by 1, we get 7. Second one, minus 15 divided by 1, we get minus 15. According to the statement, A divided by 1 is equal to A. And 1 divided by A is not equal to A. Let's check. A equal to 7, substitute the value, we get 1 divided by 7 is equal to 1 by 7. Therefore, 1 divided by A is not equal to A. There is no identity element of division. Let's see division of an integer by itself. Statement: if A is a non-zero integer, then A divided by A is equal to 1. Let's see the example. First one, minus 18 divided by minus 18. Now we have to divide, cancel the sign, and 18s are cancelled, we get 1. Second one, 7 divided by 7, we get 1. Third one, 125 divided by 125, we get 1. Therefore, A divided by A is equal to 1. Let's see the example of division of integers. First one, minus 40 divided by minus 5. Let us find the solution. Here 40 is dividend, 5 is divisor. 8 5s are 40. 40 minus 40, we get 0. When we divide a negative integer by a negative integer, we get positive integer. Therefore, minus 40 divided by minus 5, we get 8. The quotient is 8 plus 8. Let's see third example. 72 divided by 12. 72 is dividend, 12 is divisor. We can divide. 6 12s are 72. Now we can subtract, we get 0. Therefore, when we divide a positive integer by a positive integer, we get positive integer only. Therefore, 72 divided by 12 is equal to, we get 6. That means plus 6. The quotient is 6. Let's see example 16. The product of two integers is minus 64. If one integer is minus 16, find the other. Let us find the solution. Before do the sum, note down what is given. The product of two integers equal to minus 64. One of the integers is minus 16. The other integer, now we have to find the other integers. Let the other integer be z. We have to assume any one letter. Therefore, one integer minus 16, other integer z. So, we get minus 16 into z equal to minus 64. Now, we have to find out the z value. So, minus 16 transpose to RHS. Here, change the sign. This side multiplication, this one going to RHS side, change to division. We get z equal to minus 64 divided by minus 16. Now, cancel the sign and also cancel the number. 16s are 16, 4 16s are 64. Therefore, z equal to 4. That means the other integer equal to 4. Let's see exercise 1.3. Third problem, write the questions. First one, minus 124 divided by 4. Let us find the solution. When we divide a negative integer by a positive integer, we get negative integer only. Here 124 is divide and 4 is divisor. Now we can divide. 3 4s are 12. 12 minus 12, 0. Now bring down 4. 1 4s are 4. 4 minus 4, we get 0. Therefore, minus 124 divided by 4 is equal to, we get minus 31. The quotient is minus 31. Let's see fourth problem. 45 divided by 9. Let us find the solution. When we divide a both positive integers, we get positive integer. Let us find the solution. 45 divided by 9. 5 9s are 45. We can subtract 45 minus 45, we get 0. Therefore, 45 divided by 9 is equal to, we get 5. Quotient is plus 5. Let's see fourth problem. Simplify. First one, 16 into minus 9 divided by 24. Let us find the solution. 16 and minus 9 are grouped. 16 into minus 9 divided by 24 is equal to, first we have to solve it inside the bracket. 16 into minus 9, we get minus 144 divided by remaining 24. Now, when we divide a negative integer by a positive integer, we get negative integer only. Therefore, here 144 is divide and 24 is divisor. Now we can divide 144 divided by 24. 6 24s are 144. 144 minus 144, we get 0. Therefore, 16 into minus 9 divided by 24 is equal to, we get minus 6. The value is minus 6. Let's see fifth problem. The product of two integers is 84. If one integer is minus 12, find the other. Let us find the solution. Before do the sum, note down what is given. The product of two integers is 84. One of the integers equal to minus 12. Find the other integer. Let the other integer be a. We have to assume any one letter. The product of two integers equal to 84. One of the integers minus 12. Find the other integer. one integer minus 12. So minus 12 into other integer, let the other integer be a. So minus 12 into a equal to 84. So a equal to minus 12 transpose to RHS. The expression is a equal to 84 divided by minus 12. 7 12s are 84. So a equal to minus 7. Therefore, the other integer equal to minus 7. One integer positive, another integer negative, we get negative integer only. Therefore, the other integer equal to minus 7. Sixth problem, if m equal to 12 and n equal to minus 4, check if m divided by n is equal to n divided by m. Let us find the solution. Here given m and n value, m equal to 12, n equal to minus 4. Let's check LHS. M divided by n is equal to m value 12, 12 divided by n equal to minus 4. We get 12 divided by minus 4. 12 divided by minus 4, we get 3. When we divide a positive integer by a negative integer, we get negative integer only. So, m divided by n is equal to minus 3. Let's check RHS. N divided by m. N equal to minus 4 divided by m 12. So, we get minus 4 divided by 12. 1 4s are 4. 3 4s are 12. Therefore, n divided by m is equal to minus 1 divided by 3. Therefore, minus 3 is not equal to minus 1 by 3. Therefore, m divided by n is not equal to n divided by m. Thank you, students.